In this video, I'll be telling you how radiocarbon dating helps to detect forged art. So, radiocarbon dating. Let's start with the basics. What is it? Why is it important? And how is it applicable to detecting forged artwork? Radiocarbon dating is a way to determine the age of a material by looking at its ratio of carbon-14 to carbon-12. Living things are comprised of carbon, most of which have atoms with 6 protons and 6 neutrons. This is what we call carbon-12. High into the atmosphere, another type of carbon can be created. If a nitrogen atom is hit with a cosmic ray, the nitrogen atoms can turn into carbon, and this carbon has 6 protons and 8 neutrons, which we call carbon-14. Living things are constantly taking in and letting out carbon dioxide, and because of this, living things will have the same ratio of carbon-14 to carbon-12 as there is in the atmosphere at the time that it's alive. Now, because carbon-14 is unstable, it decays. So when a living thing, such as this flower, dies, the unstable carbon-14 will decay back into its original form of nitrogen at a half-life of about 5,730 years, while the stable carbon-12 remains the same and does not decay. So since we know that carbon-14 has a half-life of 5,730 years, let's look at a visual representation of that decay. On the y-axis, we have the percentage of carbon-14, while on the x-axis, we have the length of time in years. As we see by looking at this graph, the percentage of carbon-14 drops steeply within the first 30,000 years or so, coming to almost a plateau by the time we reach 50 to 60,000 years. Because of such a low percentage of carbon-14 left after that time period, there's not enough left to make an accurate conclusion about the age of something. For this reason, scientists reserve radiocarbon dating for materials up to about 60,000 years old. In order to use this method for materials that are older than that, scientists use unstable elements that have much longer half-lives than carbon-14. At this point, you may be wondering what the link is between radiocarbon dating and the detection of forged art. Let's think like artists for a moment and break down the physical parts that make up a painting. First, we have canvas, which has been used for painting as early as the 14th century. Canvas is typically made of a natural fiber, historically hemp, but most modern canvas is made of cotton and linen. Next, of course, we have the paint. Oil paint, which is typically the type of paint used for canvas, is made up of 2 components, a binder and a pigment. A binder is a drying oil medium, such as linseed oil, walnut oil, or poppy seed oil. And then we have pigments, which can consist of a wide variety of powdered substances, such as insects, minerals, stones, and plants. Since all of the parts that make up a painting, like hemp for the canvas, and linseed oil and pigment from materials like plants for the paint, all come from things that were once alive, they all have carbon. Because of this carbon, we are able to determine the approximate age of each of these once living things. We can do this by looking at their ratio of carbon-14 to carbon-12, which we can extract from materials in paintings. Here I've inserted a wonderful clip from the University of Delaware where they are showing the historical methods of creating oil paint. This part of the clip in particular is great because you can see the raw minerals used for the pigment on the right, and then on the left you can see the flax seeds that were used to create the oil. Up until recently, radiocarbon dating was largely seen as an inefficient, ineffective tool for the dating of works of art. This is for a few reasons. Previously, there was much more risk associated with using radiocarbon dating on pieces of art, because in order to extract a usable sample, large pieces of material from the painting were required. This is an issue because you can risk the integrity of the piece. Samples can also be easily contaminated, leading to false results. All of these things could be possibly damaging a genuine piece of valuable artwork. Scientists recently put the advancement of methods in radiocarbon dating to the test on this painting, Village Scene with Horse and Hawn and Company Factory. This piece, which is signed and dated Sarah Hahn, 1866, is a known forgery done by forger Robert Trotter. With new technology, now samples as small as a single thread from a canvas are usable and accurate. First, the sample is carefully cleaned in order to remove anything that may skew the results, such as the removal of varnish that may have been applied long after the creation of the piece in an effort to restore it. In this photo, we can see where the sample was taken that was analyzed, in the blue triangle. In the photos underneath, you can see how large the samples were, or how small, I should say. After being cleaned, the sample is placed into a machine called an elemental analyzer. The elemental analyzer burns the sample, converting it into carbon dioxide gas. The gas is then trapped and fed into what is called an accelerated mass spectrometer, which measures the gas's ratio of carbon-14 to carbon-12. With the process for radiocarbon dating becoming more technically advanced, it is now much more efficient and effective. Radiocarbon dating has become a great complement to techniques that already exist. It comes in particularly handy when examining modern forgeries. Robert Trotter's forgery of Sarah Hahn's village scene was done on an old canvas, which analyses of its fibers tell us that it could have been made anywhere from the late 17th century to the mid-20th century. This time period would line up with the date on the back of the canvas, 1866. When the work was examined further, taking samples from the paint, researchers saw a high proportion of carbon-14 in the binder. That high proportion tells us that the paint's binder is made from seeds that weren't harvested until after the 1950s, possibly as late as 1989. So how does this high proportion of carbon-14 tell us that the seeds in the paint's binder couldn't have come before the 1950s? Well, some very specific events occurred during that time period that account for the high amounts of carbon-14 in the atmosphere. The dawn of the atomic age. Due to the testing of nuclear bombs in the 1950s, the concentration of carbon-14 in the Earth's atmosphere doubled. This specific event in time gives scientists a known reason for the increase of carbon-14 in the atmosphere. Keeping all of that in mind, let's look at the age plots generated by the samples taken from the canvas and paint of the village scene painting. Looking at the paint sample's age plot, we can see that there is a clear spike in the amount of carbon-14 after the 1950s, which tells us with 95.4% accuracy that it would be basically impossible for the paint to have come before the 1950s, when the painting claims to have been made. This data contradicts the age plot of the canvas sample, which doesn't have this spike in carbon-14. The contradicting ages of these two materials is what allows us to come to the conclusion that the painting must be a forged piece of art.